In this example, we are going to convert each of the following. The point 2 comma pi over 3 from polar to rectangular coordinates. And then we'll also do negative 5 comma 2 from rectangular to polar coordinates. In order to change the first pair from polar to rectangular coordinates, we would like to use equations that involve both r and theta, which are what my two pieces are right now, r and theta. Two equations that involve r and theta and allow me to solve for x, and another one to solve for y. In this case then, I will be using r cosine of theta is equal to x, and I'll also be using r sine of theta is equal to y. The reason why I wouldn't use something like another equation, x squared plus y squared equals r squared, is because even though we know what r is, we do not have either x or y at the moment, and therefore would still have two unknown variables. I want to use equations where I only have one unknown variable, x and y in each of these. In this case then, just plug in r and theta. We would have 2 cosine of pi thirds, as well as 2 sine of pi thirds. We should not need a calculator for this purpose, as we should know cosine and sine of pi thirds. Cosine of pi thirds is a positive 1/2, whereas sine of pi thirds is a positive square root of 3 over 2. Multiply accordingly. 2 times 1/2 would give me just 1. And 2 times square root of 3 divided by 2 will just give me square root of 3. Meaning I now have my coordinates in rectangular as 1 comma square root of 3. That would be my answer there. When I'm changing from rectangular to polar for the second case, what we will do is use equations that involve x and y and allow me to solve for r, and another one that allows me to solve for theta. This is where we would use x squared plus y squared equals r squared, as that allows me to take x and y and solve for r. And we will also use y over x is equal to tangent of theta. That will allow me to take y and x and solve for the angle measure of theta. For the first case, this is just the Pythagorean theorem, really. I have negative 5 squared plus 2 squared is equal to r squared. And I also have 2 divided by negative 5 is equal to tangent of theta. Well, for r, there's not much that really needs to be done there. That'll be 25 and 4 makes 29 equals r squared, or just r is equal to the square root of 29. However, for the theta angle measure, we would want to apply arctangent to both sides and say arctan of negative 2 over 5 is equal to theta. However, that is not quite accurate. Be very careful about where our x and y coordinate is. Negative 5 comma 2. If I were to graph that on a coordinate plane, that would put me 5 back towards x, 2 up towards y, meaning my point is somewhere in quadrant 2. The reason why we need to be careful about that is because arctangent of negative 2 over 5 will result in an angle measure in quadrant 4 between negative pi halves and 0. we need to fix that, adjust that, so that the angle measure is actually in the correct place in quadrant 2. So what I will do to that is take whatever arctangent of -2/5 is, and I will add pi to that. This now defines the correct value for theta, or one correct value for theta, I should say. We could approximate that, but there is no need to do so. I will just keep my answer as it is, and I will say that my point is now in r comma theta form. Square root of 29 as r, and then arctan of -2/5 plus pi as my theta value. That would be my answer there.